constant grinding, wrenching change that I inflict on you and everyone around me.
I love sarcasm.
Yeah.
And we're live, so go ahead while we're live.
So I want to explore not using Hangouts on Air and start an actual regular streaming software to do the actual production environment for this.
So not YouTube Live, but something else?
It would still be YouTube Live, but you remember last week you were trying to set up that stream?
Yeah, and it failed horribly.
Well, yeah. So we use a streaming software that lets us live stream, and then we have it sort of, so we don't rely on the Hangouts on Air to pull together what the show looks like.
Okay.
Make sense?
Yeah. And
then we get a lot more flexibility. We can put up, we can camera switch. There's a ton of stuff that we'll be able to do.
Yeah, so. No. This is, I was trying to figure out how to do that last week and then hit the expletive it. I'm setting up a second one.
Yeah, exactly. Now, screw it. We're just doing Hangouts on Air. So,
yeah.
Oh, I forgot to do a really important.
Did you forget to write the intro again?
I was so excited to start. No, I did that. I was so excited to start the show that I forgot here to give you the video feed.
Susie did that. Susie covered you this week.
Well, what? No, she didn't.
Yeah.
No.
Yeah, she did. Susie sent me the YouTube link.
Oh,
yeah. Tweeted it like an hour ago. Maybe 2 hours ago. I lost Twitter. I have too many screens. Hello, everyone. Welcome to Fraser and I prattling incessantly at one another.
That's what people come for. They want this. Have you got the link to the pop-out chat?
No, that I don't have. That you are welcome to send me.
That's it there for you.
Thank you.
Yeah. So I got a new lens for my camera.
You have the T36?
No, I have the Mark 5.
Oh, that's right.
The 5D Mark 5. Yeah, Mark 2. Yeah, so upgraded. So I figured a full frame sensor needs a full frame lens. So
yes, it does.
I ordered their 24 to 70, their L series. So it's going to let me not have to use my Rokinon lenses, which would be nice because they're great, a lot of glass, but they're manual aperture, manual focus. So I can't really run and gun with the camera, and I can't go out and just I'm going to take a bunch of pictures and autofocus. So I just left those lenses at home, and I've always just relied on 50, but now I got a proper lens. So anyway,
that's awesome. I'm
a proper computer and a proper lens. I feel like I've grown up now.
Yeah, I've had the proper computer, but I still don't have full frame, so I'm hoping to upgrade this year. Not quite sure when. So you have the Mark series?
Yeah, I have the 5D Mark II.
Okay. Yeah, that's one of the ones I've been looking at. Well, I don't know what Mark I've been looking.
Well, the Mark III is the new one, and it's fancy.
Why are they going backwards with numbers?
No, 5D Mark II and 5D.
Oh, I thought you were saying it was a 3 Mark III. Never, just ignore me.
No. So that's the camera that I use for all of our videos for the Universe Today, for the Guide to Space. I'm going to say hello to some people. Let me see. We've got Adalpha for Cap, Adventure Prime Fire, Andres Munoz, Arnold Post, David Joseph Wesley, Elad Avron, Guido Bibra, Helg Björkhag, Jason Rambos, JXP, is it J15? Jim Meeker, John S., Johnny Zed. Welcome to Canada, Johnny Zed. Michael Jobin, Michael Meyer, Michael Murphy, Nancy Graziano, Phil Wilcox, Psycho Cat 749, Quickie Koala, Richard Strassel, Rinstro, Ross Betts, Sylvan Westby, Stephen Walker, Steve Chisnell, Thomas Traniker, Tom Nathy, and Valdagast, which is the best evil boss enemy of some Dungeons and Dragons campaign, isn't it? Enter the dungeon of Valdagast.
Yeah, no, that's true.
Yeah, I like it. Sounds great.
I feel this need to point out to Quickie Koala that there's a serious syphilis problem among koalas, and your name disturbs me greatly because I know too much science.
Adventure Prime Fair says Fraser tried to capture an asteroid in KSP. No, that sounds awesome. I should totally do that. Oh, that would be amazing. Yeah, I got to do more KSP. Wah, wah.
I need to log into YouTube as myself before I start commenting as learning space.
So thanks to everybody who suggested that we use try and come up with a 404 error as our topic, and we couldn't pull it off last week, so we were able to pull it off this week, and so we got error 405, method not found. So literally an Apache error code generated an episode of Astronomy Cast.
Well, it didn't generate it, but it certainly inspired it.
Inspired it?
Yeah, if error codes could generate this show, we'd be out of a job. I know how to generate error codes.
Yeah. People have to remember, you're the better web server administrator than me. You're the I'm the one with the computer science degree. You're the one with the astronomy degree. Actually,
I have a minor in computer science.
Yeah, you are both a better computer science person and astronomer than me. So I think you really are able to kind of take the whole collection.
I enjoy programming. You enjoy management. So we balance each other out.
Totally. Okay, cool. So if you have no idea what this kind of rambling thing is that you've stumbled into, this is going to be a live episode of Astronomy Cast. So we're going to take half an hour, however I feel. We will talk about. I have this second screen now, so I'm like looking over this. It's bad. I should remove everything from the second screen. So I just look at the camera. Hello. Yeah. So we're going to take about half an hour. We're going to talk about the things that we can't know, impossible to know, forbidden knowledge. And then we'll stick around and answer your questions about space and astronomy, or we'll just chat about pancakes, or how the Martian got robbed.
I now want pancakes.
And the Martian to not get robbed, but can't have what we want. So, so I'll hang up, yak with you guys about, or just play Kerbal Space Program if that's what you're into. Okay, great. Let's do this thing we call Astronomy Cast.
Okay. I am finding my record button and I am pressing. Oh, I forgot to turn off my hot water heater.
Just said, I love how my phone reminds me this is starting. Wouldn't you all love to know when Astronomy Cast is starting and have some kind of reminder in your... so Ross, could you tell everybody what you did? And then you can all do the same thing.
Yes.
Yeah, that would be great. Steve Chisel says we should do a whole episode about the Kerbal Space Program. That would make for a terrible podcast.
So Jim writes, warn me when the null pointer exception episode is scheduled. I think that's called several weeks of my dissertation.
Is that at null? Can we do a null episode of
we can talk about zero.
Yeah, episode null. No, but not zero, null.
We'll sort that later. I need to look up what number that error code is. Okay, so I have now stopped my water from boiling loudly, and I'm ready to press record. Are you ready to press record?
Yeah, it was like a screeching sound in my ears. No, I didn't even hear it. Didn't even know what's happening. Okay. Ex Machina was robbed, says William Van de Beek. Totally. Man, that was one of my favorite movies of the year. Although Fury Road was totally celebrated like it deserved.
Yes.
So that really helped. Nancy Graziano says that episode null can discuss dark matter, dark energy. Okay, so Nicole Gatnikar says, go to the settings at the side of Astronomy Cast and click on send me all notification, and then it notifies you. So there you go. Send me all notification.
Oh, Elad Avron's reminding me I still haven't seen Ex Machina. I need to do that tonight.
Yes, you must. It is the most unsettling handling of AI that I've ever seen. That's been handled in proper media, like in mainstream media. I think her is my favorite user interface. Because they nailed it, and now like Google and Alexa and all the they're all trying to catch up.
Yeah.
But but Ex Machina goes the other way and just kind of goes, this is what's probably going to happen. So
yeah,
I really enjoyed it. This is what an alien artificial intelligence looks like.
Yes.
Yeah. So, okay, well, let's do this thing.
Okay.
Yeah, Ex Machina is on Netflix in Canada.
Yeah,
right?
yeah. I got sidetracked with rewatching Jessica Jones when I went to see it. Don't ask. Long
Oh,
story.
you're saying you haven't seen it either?
No, I haven't.
Oh.
I fail occasionally. I have seen Fury.
If I'd known, I just would have nagged a lot harder. So just you have to tell me which of the important things you haven't watched so that I can nag. Anyway, this is the worst episode ever. Let's get cracking. Tell me when you're ready.
I'm pressing record.
Okay.
It's recording. Hi, Preston.
I'm also recording. Oh, wait a minute. No, stop.
Okay, failed.
I was. What the tracks? Let's go to mono.
I deleted what I started.
Oh, I feel like I'm the one letting us down. Okay.
It's all right. It's all right. Colin Jones is writing. All your notifications belong to us, and you, Colin, get nerd points.
I have that shirt. Okay. I've stopped. Let's see if now recording. Let's keep it in mono. No. Tom, you're stupid. All right. I'm just gonna. Okay. I'm gonna record in stereo and then I'm gonna flatten it to mono.
That's fine. All right. That works.
Okay, ready?
Yes, I'm pressing record. Hi, Preston. You just missed so much chaos. You're so lucky you only get the audio.
Well, you can always go back and watch the version on YouTube and catch it.
If you want to hear us be insane. But Preston, we love you, even if you miss our insanity.
I'm getting background hums and buzzes on my recording.
Do I need to stop again? I'm going to stop again. Okay. And now you guys get to listen to us say hi to Preston like 4
I want to hear what that sounds like. Hey, hold on one second. I hear what that sounds like. Oh, it's not coming from... Apologize. I don't like the way this looks.
I'm going to fuss with my light. No, I'm not. I'm going to leave my lighting be.
Is that it?
I like the way Voldegast are like live, everybody.
Sorry. It's okay.
Okay.
Yeah, I think it's all right. Sorry to shush you. It sounded like it. So, what was the shush heard around the world?
It was
with this. Okay.
Yeah.
All right.
Are you happy? Can we start again?
I'm ready.
Okay. I'm pressing record again. Hi, Preston. You don't know it, but this is the third time we've started the show. And each time we've said hello to you. So hello a third time.
Hello, Preston. All right. I actually started a little behind you, so hopefully Preston can catch where it actually belongs when he syncs it up. Anyway, let us begin this show. Astronomy Cast, episode 405, Method Not Found. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos. We hope you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Good. When I say the director of CosmoQuest, that really means a lot these days. How are things going with CosmoQuest?
I have become far more of a paper pusher than I ever meant to become. I always wanted to be that person out there doing things, but now I'm the person out there enabling other people to do things, which is like satisfying because there's like people with jobs and stuff. But wow, paperwork, wow. All of you out there who are career managers and bureaucrats, you're doing like God's work.
Yeah. I have a whole army that surrounds me to handle the paperwork because if I didn't, it would just pile up like snowdrifts in my house.
Yeah. Yeah. So yeah, it's going well. We still have a data management position open. And the reason that it's still open is mostly because we've been so busy getting subcontracts out to all of our collaborating institutions that we haven't had a chance to look at job applicants yet. So if you are a baby PhD looking for your first postdoc, we may have one for you.
Right on.
Yeah. cosmoquest.org/x/open-jobs.
That sounds great. All right, so last week we talked about knowledge, what we do and don't know. And this week we talk about questions which are impossible to ask, where the answers don't exist, where the data can't be found. And really, we wanted something that would line up with an obscure error code in Apache. So we forgot to do the 404, but we got the 405 in there. So I think that's what really matters. Okay, Pamela. So let's move on then to our seeking knowledge to places that just you shouldn't even ask the question.
Well, it's not that you shouldn't ask the question. It's that when you ask the question, the universe responds with method not found. There's just some questions that we don't have the ability, not because of lack of technology, that was last week, but we don't have the ability because of the nature of the universe to find the answer.
Okay, so let's go with one that I think people are familiar with. They've heard it before. And this is this idea of the uncertainty principle, because this is a great example of one where your attempt to find the answer will mess up the answer. You're wrecking it. So let's talk a bit about how that works.
So the uncertainty principle says that you can either know where something is or how fast it's going, but you can't know both at once. And this isn't, again, one of those limitations on how well we can measure things. This is a fundamental issue in the universe where the relationship between where something is and its momentum, there's a constant in there, and you just can't have you can't have zero uncertainty.
So what happens, like, as you're trying to measure one, what's happening to the other one? So like, like if you in the lab, I'm sure this has been backed up in the lab to incredible detail, the better you measure the momentum, what happens to the position?
It's not that something happens to the position so much as the techniques that allow you to know one with the fundamental way the universe works don't allow you to get at the other one simultaneously. You basically can't get there from here.
And so if you measure one with incredible certainty, like its position or its momentum, that other question becomes a field of probability that you can't address.
Yeah.
And if you then switch over to the other one becomes this field of uncertainty that you can't address. And you can't. So what if you measure one and then you quickly move over to the other one and you measure the other one?
Well, the sucker's in motion. So since it's in motion, you can go from quickly knowing one to quickly knowing the other, and the uncertainty still is there. So mathematically, what we're looking at is the uncertainty in how well we know the position multiplied by the uncertainty in how well we know the momentum is always going to be greater than some constant that happens to be h bar over 2. It's just a number. Another way of looking at it is velocity is how a lot of people look at it, but because relativistic stuff can be involved, you need to use the momentum equation because the mass is tied up in there as well. So even though you may always hear position and velocity, it's really position and momentum, just to get tricky with you.
That's good. Now that saved you probably 100 letters. So it's perfect. Centripetal, centrifugal, centripetal, centrifugal. Right. But I think what's really important, right, is you mentioned this thing that it's not just like you're doing it's not like your techniques aren't great and your tools aren't great and you really, really work at it and you make the most perfect laboratory with the most perfect measurements, with the most perfect equipment. There is a place you can never get past.
Right. And this has to do in part with the wave particle reality of our universe, where you have to factor in the fact that even stuff is really a wavelength. And where exactly is the center of a wavelength? Even you and I have our own intrinsic wavelengths. It's just for us, as we talked about a million episodes back, the size of our wavelength is smaller than our body. But when you start looking at these little tiny particles, their wavelength is not all that different from their particle size, or at least what we imply is their particle size. And so you're kind of stuck trying to figure out how to untangle the center of that and the velocity at which everything is traveling. And quantum mechanics says nope. It just says nope.
And that's got to feel just, I don't know.
Why? Why does this bother people?
It bothers people. Okay, so I mean, this was sort of well, and we're going to come back around to this, right? Like, we're going to get to the place where you as our counselor tell us there will be things that we can never know. We need to be all right with that. But we'll get to that as we sort of approach the end of this episode. Let's move to another place that let's talk about the in that sort of same category as the what's outside the universe question.
Okay. We can't
what's outside the universe? What's the universe expanding? We did a whole episode about this, but I think, I've had to explain it 100 times now. I'm sure so let's sort of like come back around as we're explaining why, again, that is the kind of question that you cannot find the answer to.
And here the issue is there's no method to see outside of our space-time continuum. And there's no physics to say that there should be a method to see outside of our space-time continuum. As far as we know, our space-time continuum is complete unto itself. And it's kind of like we live on the surface of a balloon with no hope of burrowing through the surface or jumping off of the surface. We're just stuck here.
My favorite explainer on this is it's called No Edge. And it's oh my god, I forgot his name. It's an alien from Betelgeuse on YouTube, and the video is called No Edge, and he explains sort of that it's kind of like a video game, like asteroids, where you go from one side of the screen to the other side of the screen, and so if you increase the size of the screen in asteroids, you just keep scrolling around, whether you go off the top of the screen or whether you go off the left-hand side of the screen, right? Like, what's outside the screen in asteroids? There's nothing. So just do one more dimension, right?
Yeah.
So just go, imagine if you're in asteroids and you go towards you in the game and you pop out on the back of the screen and you keep moving back forward, or go the other way, right? And so if you expand that, you can make it bigger, that you can travel further, but it's still a finite volume of space that has no outside. You can never get there.
Yeah. It's okay.
Yeah,
I'm just going to keep saying that a lot this episode.
It's okay. It's all right. You can't know this all, and that if it is outside the universe, it's Zod from Betelgeuse. That's it. Zog. Yeah, a bunch of people in the chat got that. Yeah, Zog from Betelgeuse. Has a great series, and highly recommend you search this up on YouTube. And then this idea, right, that if it's outside the universe, but you could measure with the laws of physics of our universe, then it's, by definition, part of the universe.
And so there's just no method to see what's outside of our universe.
What about before the universe?
We don't even really have a way to see before 300,000 years ago. So yeah, no, there's no method. There are methods to see.
You mean 300,000 years after the Big Bang?
That's what I meant. Yes. Yeah. Wrong direction.
Yeah. Right. But again, right, if the laws of physics, time and space, were instantiated at the beginning of the universe, then to ask what came before the universe doesn't make sense. Okay, exactly. This is starting to not feel okay, Pamela. So
why?
Because we understand this concept of before, that we as human beings intuitively understand that for every time there is a before. How can you have a time when there was no before?
Why does there need to be a time that was before?
Because for all the times that there's always been a before.
So you're assuming that time is continuous and doesn't just stop. But if you were a photon, you'd never experience time at all.
But how could a something come from nothing, right? Like why did you decide to begin then, right?
And these are things that we don't have a method to determine. It's just there is no method to determine it.
So what do you mean when you say there's no method?
So there is a way for me to get the coffee cup off of the surface of my desk. I pick it up with my hand. I could also pick up the whole desk. There's ways for us to do this. There are ways for me to measure why I appear slightly blue if you're watching this on YouTube, and that's called a photo multiplier of some sort. That's detecting the light flux. I don't have one of those, or my lighting might not suck quite so badly. There are methods for us to do things, to measure things, to determine things. There's technology that is defined through the physics that governs our universe. Occasionally, physics comes along and says, no, you're not allowed to understand that. You just can't get data on that thing. There is no information. And when it comes to anything before moment zero of our universe, the arrow of time that we're dealing with, according to most general ideas of how our universe functions, the time originates right then and there. Now, there are a few theories out there that say that's not when time actually originates, and they can work to explain this in different ways. Sean Carroll's done some work on this problem. But even if we solve the arrow of time issue and time originating at zero of the universe, we still don't have a mechanism, according to modern physics, to make any measurements of that time.
And so then all you're doing is philosophizing and having an opinion, right? And like when you have this argument with people, all they're doing is having an opinion, right? Like, I like chocolate ice cream best.
Yes.
My feeling is that I'm going to live forever and I can eat as much chocolate ice cream as I want. But, you know, just because you feel a certain way doesn't mean the truth is different. And even if you do figure out a way to go before time and to go like, oh, it turns out time did exist before the universe and the universe is just a bubble in a multiverse. What came before that? Like at a certain point,
there from here.
You get there from here, right? And so at a certain point, you have to come to grips that there are questions that there will never be answers to.
What's inside of an event horizon, one of the ones that bothers people significantly, and it's not even answering any fundamental questions about life. Like, what came before the universe is kind of a fundamental philosophical and religious question, but what's inside of a black hole is just annoying to not know. But there are people who are deeply, deeply annoyed not to understand what's inside of an event horizon.
Some of them might be in this room itself.
Yes. But it's simply a matter that because nothing can go faster than the speed of light, another thing, method not found. There is no method to go faster than the speed of light. We can't send a probe in and have it bring data back out. In fact, we can't even look for stuff to come out of the black hole in a meaningful way that we can observe information from. So again, method not found. We can't look inside of a event horizon.
Maybe, right? Because I mean, well, no, I mean, I know, you know, you're Miss Grumbly Pants, but in theory, with gravitational waves, we should, you know, with super accurate gravitational wave detectors, we should be able to see the signal of two merging black holes, for example, and try to get a sense, you know, did they merge together really quickly? Did they merge together really slowly? Did they bounce around somehow inside? Was there some kind of wobble inside the event horizon? Like there might maybe be an answer to the question as opposed to some of the other stuff that we've talked about, right?
So gravitational waves have the potential to give us some information about the timescales of mergers and other high-density collisional events that are warping space and time. But that still doesn't tell us what's inside of a black hole.
No, but it gives us another method to maybe probe. That's all, just a little bit. And same thing with the, you talked about this a bit already, which is this idea of the sort of the moment where you can't see back to the Big Bang, that there's a portion that will always be outside of our reach.
And one of the things I need to corner some cosmologists on is I've seen some news stories where people are talking about gravitational waves allow us to see prior to the cosmic microwave background radiation. But what gravitational waves let us see are when high mass objects interact with one another, but there weren't high mass objects in any theory we've got. So there's, as near as I can tell, no reason to believe there would be gravitational waves emanating from the cosmic microwave background.
But like with the primordial gravitational waves that they thought they had seen, this was sort of one of those possible signatures. And maybe there's another way to get at those primordial gravitational waves.
And I will have to see.
Yeah.
Yeah, I'm a grumpy pants on this.
Yeah, you totally are. But that's okay. So I think one thing that's kind of interesting as well is that they're sort of hilariously, so hold on. There are questions that we can know the answer to today that people in the far, far future won't know.
Yes.
Right? Which is sort of like, we ask, is the universe finite or infinite?
Yes.
We can never know. We might never know, because if all you can do is receive signals at the speed of light, how can you know what's outside of the radius of the universe?
And if all the understanding of the universe that our civilization has and any other civilizations that are out there have is lost, then someday in the far distant future, when all of the galaxy clusters are just islands that have nothing else within their Hubble horizon, then those peoples will have no ability to get at the idea of inflation or large-scale structure or any of these other things that we can observe today that will go beyond the observable horizon of those peoples of the future.
Yeah. So someone 1 trillion years from now won't know that there was ever other galaxies.
Right. Well, they'll know there were other galaxies. They won't understand that there was other galaxy clusters.
Or that there was a Big Bang.
Exactly.
Which is crazy, right? That we happen to live at a time where this question that we could have answered, but yet in the future. And I mean, I guess if we happen to live 200,000 years, after the Big Bang happened, we could answer that question too. Except we couldn't see anywhere because everything would be opaque and we would also be on fire. But
and made of just hydrogen, helium, and trace amounts of other stuff. But yeah,
that we wouldn't be able to know. What are some other places where we can't know?
So those are the big ones. The other things that we struggle with is, how do you detect theorized particles like the graviton? We have no way of detecting it, simply because it just defies all of our abilities to detect, which is highly annoying. So it's this massless thing that travels at the speed of light and doesn't interact in any ways that we have a method to discover. So is there a graviton? Don't know, and may never know. That's another one of those things that's just kind of annoying. There's also the question that you'd think would have an answer, but it leaves physicists getting shouty with one another of, does gravity philosophically bend space-time in a way that manifests itself in all of the ways that we think of as bending space-time? Or is that just a construct that we've come up with in our heads, but the actual universe is just plain old rectilinear space with none of these deformations? It's just how the particles fly. And so there's that philosophical, is space actually bent, or is space not actually bent, but this is a good mathematical construct? I don't know if we can answer that one either.
Does time go in the direction that we think it does, right? Or does the whole thing run backwards? Because mathematically, if you do the time and the parity and the charge, you can run the whole universe backwards.
Well, so there I think it starts to get into simply word choice. Forwards, backwards, that's a word choice. But there are other things that start to get into the same idea as the uncertainty principle. So for instance, it's generally thought, and there's a few experiments that people are arguing over the interpretation of, but it's generally thought that you can't see a piece of light, a particle, a photon of light, as both a wave and a particle simultaneously. So it may be that we have to treat things consistently as waves or as particles, but only by doing things that may actually just be essentially physical magic that's explainable. You can't actually simultaneously see the wave and particle behavior.
And tides go in, tides go out. You can't explain that.
I can explain it badly, just like everybody else.
Yeah. That was a joke. So then one, I think, that really intrigues people, we did a whole show on this. I mean, we're intrigued too, which is this idea of the multiverse, right? That every moment we make a choice, every time a particle, a probability event happens, it could be generating entirely new multiple universes, which the math works, but we could never access those other universes.
There's nothing stopping there from being an infinity of other universes out there, and we just can't get there from here. So I just want to bring up there's the movie Dr. Strangelove that has the fabulous title of How I Learned to Stop Worrying and Love the Bomb. And I'm not going to love the bomb, but it might be that it's okay to say how I learned to stop worrying and love what I can't know. And it's all right for there to be things that we just can't know. It's, I think, more pleasing in some ways to have a universe that isn't just so, but instead has certain things that are just sort of, this is the thing that you can't know yet or ever. And take that, humans. Now you get to be perplexed forever. That's kind of cool to me.
Yeah, well, and this is where I think you become our counselor, right? Which is that I think for a lot of people, and I'm going to definitely put myself in that camp, I'm comfortable to say I don't know, but I'm super not comfortable with saying I can't ever know. That my hope and faith is that these questions are just a matter of not having enough computational energy, not having enough time spent on the problem, not enough Einsteins being born and figuring this stuff out. But I know in my heart that that's wrong, that there are going to be stuff that you have to just say, that's a mystery, and we'll never know the answer to it. And
I think this comes with the difference of being able to accept wonder or not. Today's apparently the day of quotes. I brought this up last week, and then I went off and actually found it. There's a quote by Thornton Wilder in the play Our Town, and it has Emily, the lead character, saying, "Oh, Earth, you are too wonderful for anybody to realize you. Do any human beings ever realize life while they live it, every minute?" And the stage manager responds, "No. Well, the saints and poets, maybe they do some." And this idea that we can't fully understand how wonderful our universe is just with math and science and physics and thinking, that there's some things that you just have to wonder at. And that's where the poetry sometimes has to capture the things that the math can't.
Right. But by your definition, that stuff doesn't capture it either. It just makes the not knowing feel a little more palatable, you know? Like you're still swallowing the same bitter pill, but now you're experiencing a little tingly wonder and joy as you consider the bleak possibility there's going to be stuff that we can never know the answer to.
And I think it's okay to sometimes have universe light as watered down in poets trying to express things that math and science can't, because our meager little human brain just can't fully comprehend that it's okay to not know.
Yeah, and I love to have this conversation with people, and where I'll say, like, you know, where do you think the whatever, right? Like, where do you think the universe came from? Like, I don't know. And I'm cool with that. And if you think you do know, you're wrong. So you don't know just like I don't know, and I'm okay with it, and you're not. So suck it, certain guy. So but I do like to have that argument with people, right? Which is just like, you know, they don't know, and I don't know, and nobody knows, and that's okay. You don't have to know. So here we are at the end of Astronomy Cast, knowing so little.
And that's okay.
Yep. All right. Thanks, Pamela.
Thank you, Fraser.
Okay.
We survived.
We survived. Should I save and export this now and then kill
No.
and drop on? No, I shouldn't, but I don't want to forget to. I either forget to re-enable my Dropbox or I forget to save the episode. But okay, all right.
See, what I do is I don't close Audacity until all the Dropbox stuff is safely uploaded.
Yeah, okay.
And that way I have the window taunting me.
All right. Hey, everybody, patiently. Yeah, so someone mentioned magnets, and that got me thinking. Right, Cantor said magnets. Tide goes in, tide goes out. You can't explain that. That was what's his face? The guy from Fox. Then somebody please help me with my reference. Oh yeah, Gustav Wawrinski said magnetus. So a bunch of people talking about the. So Nicole Ganikar says, do you know about the Berenstain Bears controversy? This is about the possibility of other dimensions. If you remember it as the Berenstain Bears,
yes,
then you might be from a different dimension. So yeah, Bill O'Reilly, that's it. Yeah. So look into that. It was awesome. Yeah, Ross Betts, the insane clown posse is the magnets part. And I think it was Bill O'Reilly was the tide goes in, tide goes out. You can't explain it. David Joseph Wesley says that psychologists who say that people have wonder and awe in their lives are happier and healthier. So there we are. There was a great argument in the chat about flat earthers. So people keep asking me to like do an episode on flat earthers. So let me explain my position on this. They are trolls. They don't believe it. They are just trolling to make you react. And so if you react, you are feeding them, because nobody would believe something that ridiculous. They want you to think that they believe this so that you'll freak out. And I know they don't believe it because it's too ridiculous. So I will never do an episode on the flat earth ever. And we will never do an episode of it in Astronomy Cast ever. It's too insanely ridiculous.
If you want to see it handled appropriately, the comic strip Non Sequitur did an entire series where the bratty teenage girl who rides a very amusing pony is going around being a flat earther, and her family is trying to find ways to convince her it's not actually flat. At one point, she proclaims that NASA is very good at Photoshop.
No, they have a million, if at the end your answer is everything's getting faked, and it just enrages you further. No, all trolls. I don't buy it. They need to convince me that they're not trolls. And they can't do that because I can just say Photoshop. Just everything you believe, it's all just Photoshop. So, okay.
And I'm pleased that April 1 is a Friday. So that's the weekly Space Hangouts problem to deal with hoaxes.
Yeah. All right. So hit us with some questions if you want. I'm going to start moving back. I'm looking for those little question mark icons. Adventurer Primefire says, why do magnetic fields have lines?
So
do they actually have lines, or is that just like if you zoom in and zoom out, you know, like if you zoom out, then you see lines, but if you zoom in, then really it's just magnetic strengths.
So one of the crazy things that has always deeply bothered me is, so if you take iron filings and shake them out around a magnet, you'll actually get field line loops. If you look at the sun, you get plasma loops that are coiling around the magnetic fields. And it is a continuation. It's a field, but it just happens to work out that things like to collect into these nice, friendly little magnetic field lines. I can't explain why. Someone out there may be able to. I personally cannot explain why.
Yeah, I mean, I sort of imagine, like, what is the resolution of an iron filing, right? So it's going to collect into those lines.
But you'd expect it to form a chaotic cloud of things that are pointed along the correct way. And it turns out that it's not so much a chaotic cloud as a nice friendly field line. So I'm pretty sure this has something to do with the combination of electro and magnetic fields working together as things are in motion to get into place. But it becomes much more complicated to find out why things form into these lines in a field.
Got a lot of people talking about CosmoQuest, and just a reminder that CosmoQuest is, of course, the foundation that Pamela and I are directors of, and it's all about helping regular folk do science. And we want to get your help mapping craters on the moon, on Mars, all kinds of great projects. And so a bunch of people who are viewers of the show are may or may not be members of CosmoQuest. And if you are not, you really should be. It's a, you know, and now, of course, with CosmoQuest, with its increased funding, we're going to get a lot more science done. So you should come and help us do some science. And another reminder, if you want to know a notification when Astronomy Cast happens, you should go in YouTube and set the notification so that you get nagged when we're about to start the show, that your mother gets nagged so that she can call you and remind you to watch the show.
That's just mean.
No, it's the level. It sets your calendar. It makes every alarm clock in your house go off.
But don't make your mom bother you.
It makes your dog restless.
Yeah, that's true. My phone buzzes enough that it does make the dog restless.
Michael Meyer says, just after the Big Bang, the universe was very dense. Couldn't there have been gravitational waves in that dense medium? Maybe we could detect those. Some kind of primordial gravitational waves, for example.
I'm just going to sit here and be curmudgeonly and look up what David Joseph Wesley asked about a bright supernova.
What did you ask?
12.
About a Type 1a supernova Hubble spotted this fairly bright. Even the models show it shouldn't be. We had a supernova expert on the Weekly Space Hangout about 3 weeks ago. And so if you want to sort of learn more about supernova, especially Type 1a, you should watch that episode. I'm trying to get the date that we did. It was about 3 weeks ago. Steve Chisholm wants to know, what game mods do you use in Kerbal Space Program? No mods. I just run it straight up. I haven't had a time to play a lot of Kerbal Space Program. I've been playing too much Europa Universalis. I'm not gonna lie. And Hearthstone. I play a lot of Hearthstone right now, which I love. I'm Fraser, Cain. Oh, I forget my number. If you guys want to be my friend on Hearthstone. Anyway, drop me a message somehow and I'll let you know my Hearthstone account, and then we can play against each other.
I don't have free time for such things.
Neither do I. Are you kidding me? It has to take away from something like me being a parent and a good husband and proper relationships with my neighbors and friends. Valdegast, dark rumblings from Valdegast from the bottom of the pit of despair asks, what does the red spectrum tell us about quasars?
The red spectrum, that's just the optical that's been redshifted, actually. So that's one of the strange, neat things about it. So we look at infrared spectra of quasars in order to catch all of the stuff that has been blue shifted. So this gives us access to things like the hydrogen bomber lines, the calcium K lines, all of these neat lines that are well studied in the local universe.
Pete Brumwell asks, in relation to gravitational waves, I understand the observation further confirms the theory of general relativity. What more needs to happen for general relativity to make the prestigious leap from theory to law?
That's backwards, actually. Theory is more powerful than law. Don't ask. It's weird.
Right. But we're done, aren't we?
Yeah.
Yeah.
But it was already done. I mean, that's one of the things that people leave out of all of their discussions is we'd confirmed gravitational waves. We just hadn't directly detected them. Right. So the Nobel Prize was already given.
But Einstein was out of predictions, right? Once gravitational waves were detected indirectly from binary pulsars. Thanks, Einstein.
Yeah.
Yeah.
Exactly.
So now we need a new Einstein.
So Jason Rambos is asking, are there any phenomena that are predicted in the math that we know are not actually possible? Yes, white holes, because the second they get hit by any matter or energy, they collapse. So you can have white holes and wormholes in the maths. You can't have them in the real universe.
Right. But there isn't anything that's been detected. I mean, dark energy is an example of a thing that you were never expecting, that now we don't have even the slightest concept to know what it is.
But it wasn't.
We just know it's there.
It wasn't so much predicted by the math and then found. After we had said it didn't exist, it more or less just sort of said, "Hi, I'm here," and broke all of our hearts in 1998.
Yeah.
1998 was the year the math got hard.
Yeah. Stuart Brown asks, any news on the hunt for Planet 9? Any observatories on the case? So we covered this on the Weekly Space Hangout on Friday. Astronomers have really narrowed down. They know where it can't be, and they know a few places where it could be, and they know the place where it's most likely. So you should expect people to start surveying with pretty powerful telescopes that region, and hopefully we'll get it. That would be amazing. Can you imagine? I mean, it would be like Uranus all over again. No, Neptune all over again. In that it was predicted by the math, and then it was discovered.
Yes. Yeah. Uranus was Herschel.
Yeah. Valdegast, have Fraser and Pamela ever seen Red Dwarf? Of course.
Yeah.
Everybody's dead, Dave. Everybody's dead, Dave. Nicole Gatnakar asks, does the theory saying black holes formed the Big Bang support the something from nothing paradox? So we just did an episode on the Guide to Space with Paul Matt Sutter about the black holes forming the Big Bang theory, and that it's not possible, not likely. So go watch that. And Pamela's talked about it many times. They're different. Now, they sound similar, but they're different.
There is a lot of chatter.
Yeah, there is a lot. It's great. I love the chat. Sorry, when I'm just bathing, sticking my face in the river of messages as the chat goes past. Will we ever see Fraser and Pamela in Second Life and do this podcast?
So we used to do Second Life a lot, and the audience got less and the griefing got more. So I used to do a lot of work with the Meta Institute for Computational Astrophysics, and we had our own Second Life Island. And this turns out to be a much more effective way to do it.
Yeah, Second Life was a great idea, but it almost felt just kind of ahead of its time. Like, obviously, the metaverse is going to exist.
Snow crash is coming.
Yeah, snow crash will come, and maybe it's going to be when we all have our Oculus Rifts and we're all hanging out, and it's going to be, you know, another thing. But until that time, it was really janky and it crashed a lot and it was really slow and there was a ton of griefers and it just wasn't fun. So yeah, I played around with Second Life and just thought, this is dumb. Now, I'm sorry. It's just not ready.
We don't have an Astronomy Cast Minecraft server, but I can see us eventually doing something for Cosmo Quest. We're just not quite there yet.
So I have a Minecraft server that I run for my family. I could probably do something in that world, maybe. Okay. Let me see if my kids want to administrate it,
and I have an additional kid that might be able to help because I borrow people's kids occasionally.
David Miller once asked me, F. Cain, about TV. Are you still content online, or will I see you on the Universe? Peeps, you guys are a dynamic duo. So Pamela's been on the Universe a couple of times now, right? I've been on a few television shows. The problem with television is that it is, from what I have seen, a very kind of short-sighted future. So if someone wants to have us talk on Astronomy, you know, we'll often do it, although it's kind of a bit of a pain to go and doesn't give you a lot of value. And doing, you know, we've had offers to do shows before, and it's just rubbed me the wrong way. And, you know, we've seen a lot of our friends have gotten shows, and people try to make that jump from online to television, and it's been a tough transition to make. So I am a total control freak about this kind of stuff, and I would much rather that we figure out how to grow what we're doing and this stuff online into the future of the medium, which we all know it's going to be here online somehow, right? It's not television. It's the future, it's the internet. It's why my kids like to watch YouTube all day. So we would love to figure it out. If someone wants to give us a television show, I'm not sure I would do it, is my feeling.
So the trick is when either of us are just a talking head on television. So when you see me on the Universe, when you see me on any of the other random things I've done, that's just completely free. In one case, I got flown out to New York City to record, had to take a day off work, plus all the travel time. When they come to film the Universe, they actually come here to St. Louis and record at the City Museum. And recording at the City Museum actually totally makes it worth it because the City Museum is absolutely awesome. But it's one of these things where we have to take time off work. It's our vacation days that we're giving over for unpaid labor that the networks are making money off of. And I'll do a lot to promote science. And if it's at the City Museum, I'm even more likely to do it. But those gigs where you actually get paid to host something are few and far in between. And I know I'd have to lose a lot of weight, and I'd rather be a happy chip-eating astronomer on YouTube.
Well, but that's not the point, right? The point is that they are the past, right?
Yeah.
But Netflix, YouTube is the future. And so either you try to anticipate the future and you aim for it with everything you've got, and then when the future arrives, you're ready, right? Like I knew that internet publishing of news was going to overtake newspapers and television news. Like, right. Like the moment, like 1994, the moment I saw it, I'm like, okay, I get it. This is the future. So now I have to position myself and just wait out there. Like, hey, everybody, I know you're not there yet, but in the future, you're all going to want to get your news from the internet. So I'll just start publishing now and figure it out and crack it. And now here we are, right? And we're finally feeling that things have shifted into our field now.
Yeah.
And now, what do you know? We've nestled in and made ourselves home in this space for 15 years. So I think we stand a chance at being able to do well as this whole thing moves forward. So yeah, I'd love to be offered to be the host of Cosmos or whatever, right? But I would have so many restrictions about what I would want to do and what not do that it would be really high. I would be I would be an unappetizing partner for them right now, I think.
And I mean, we're getting some funny things where I think I'm being misunderstood. People are like, "You look fine. Don't worry. Food is fuel of life." Yes, I understand this, but the reality is that in order to get one of those hosting gigs, I'd need to be a size 10, and I'm not. And so the external expectations placed on women on television are such that I went down that road before. I know where it leads. And this is all part of the TV isn't the future. These are realities that we're choosing, like everyone who's cut the cord to say, no, we're not going to buy into that mainstream driven by revenue and not driven by ideas path. And this is where Netflix with Jessica Jones is the best protagonist ever, because it was willing to go to dark places that I don't think mainstream TV would ever go. And I see Thomas pointing out we should go Netflix, Cosmic Quest on Netflix. Mm-hmm. I really think a lot of these independent, let's just do everything up front and drop it all at once. There's a whole lot to be said for that. And with Patreon and everything else, Astronomy Cast is funded by you guys. Mm-hmm. We do everything that we can. We pay Susie, we pay Preston, we pay random people who help us out doing meaningful things, and pay hosting bills and all of that sort of stuff, because you have decided to donate to Astronomy Cast.
Yeah, I mean, I have gone and interviewed people like Mike Brown and Ian O'Neill and Emily Lochtawala, and put those interviews into videos. I've made custom 3D animations and put those into videos. We release tons of videos. Like, I have written scripts for longer length style documentaries. We have all the pieces that we need to make the kind of media that we think is going to best educate and enlighten everybody out there about space. And I sort of think that the premise, like a television show like Cosmos, is necessarily the best way to even do that. I don't agree with that, right?
Yeah.
That I think that people enjoy smaller parts. Like, why not consume your space content in 5-minute, 6-minute, 8-minute pieces? If you haven't, why not binge listen to 405 episodes of Astronomy Cast? If that's what you want? Like I'm not convinced that any of these things are sustainable in the long term, and I would much rather play around in a way that I can experiment and not have to, that nothing has a consequence that is threatening to my entire livelihood and all of my hopes and dreams. I'd rather I do experiments all the time, all the time. And if it doesn't work, it doesn't work. And if it works, then I keep it. And I couldn't be happier to do that. Yeah, go ahead.
One of the things I really love about this media that you do really well is, if you're part of the mainstream media, you are constantly worried about, what are my numbers? What do my advertisers think? What does my board of directors think? So what matters isn't your audience. What matters is the big boss. And you can succeed by getting all of these people that come once and never come back again. As long as they all come once during a sweeps week, you're good. Mm-hmm. With what we do, what matters most is that community, and what you've done building up the weekly Space Hangout crew is absolutely amazing. And it's by building these relationships that I see folks doing on Patreon, and I'm still learning how to do. I need more time. It's in building the community and making the community the ones out there driving your content that I think real connection and real significant communications, education, social change, all of this is powered by not having an audience, but having a community.
Yeah. Yeah. And so as long as there are people who love what we're doing and want to talk with us and enjoy the kinds of sort of directions that we want to go with our brains and the kind of conversations that we want to have, then we're on the right track.
Yeah.
Right.
And
that's it. That's all we need. That's all we need to do. And I think that everyone's looking for permission, like if you get on television or if you sign a record deal, or if Steven Spielberg approves your script, then you will have arrived. And until that time, if you get a publishing deal, but it's all a means to the end of you actually creating genuine relationships with the people who consume the content that you're creating.
Yeah.
And it gives you more distribution, no question. But if what it does also is disconnects you from the sort of pure connection that you're making to all these people, it's not a sacrifice worth making. And because in the end, if you are doing it right, people will find you, people will enjoy it, and you will have learned to make the best kind of content that you can, and you're making the world a better place. So that is the sort of, but if Netflix wants to about space,
as long as we're going to be as bad as Neil Gaiman about saying no if things don't go the way we want.
Yeah. If he wants to do it, we'd be glad to help.
It scrolled too quickly. I saw someone saying that what they really want, it was Valdegast, said, now what I would really like is an hour with one of the hosts just to ask questions. So we actually do, for our $10 a month and higher donors on Learning Space, which I co-host with Georgia Bracey. I do office hours a couple times a month where we use Zoom to do a come on and let's just sit around and chat. There's no actual fire involved. Usually there's evening sunlight, but so those are those are an hour or so after the weekly space hangout. So $10 and higher donors on Learning Space on Patreon. So patreon.com/learning space.
Yeah. So my instinct is right now is to do more stuff with you guys. Right.
Yeah.
And, some of you know exactly what I'm talking about because you're more of a part of it than others of you. And I can't be less cryptic than that. I apologize. But the more that we can be a family and make the stuff together. And that is really the instinct we're following with the weekly space hangout, is that I'm getting out of the way and really trying to let the fans chart the course of the content in the show that they want to see, that they want, so instead of them saying, why don't you get so-and-so on the show? I'm like, okay, you're now an executive producer. Go tell them I got your back. Go invite that guest to the show. And then the guest shows up and I will give you the show that you want to see, but the guest that you want, but help me make this happen. And that, I think there's a magic there that we're trying to figure out. We've gone way long. We should probably wrap this up. But I hope people enjoy at least this philosophy of sort of where we see the future of this. And Pamela, you're perfect just the way you are.
My corn chips and I are quite happy together.
Michael Meyer wants to know when we go to Hawaii. Oh, we gotta go to Hawaii. We should just all agree to go to Hawaii at the same time.
Yeah, we keep trying to organize something, and it's beyond us to do that.
It is, but I think we should. But it's that same philosophy, right? Like it shouldn't be us.
Forget it. We're just
fans of Astronomy Cast.
Yes, organize it for us.
If you want to hang out with us, pick a place, pick a time. We will. To let us know, we'll help get the word out. We'll all show up and we'll all hang out and we'll bring some telescopes. So, and we'll even pay our own way. If you can pay our way, that would be great. But if you can't, that'd also be fine. Well, let's all come and hang out as a family and look at the sky. So, if anyone wants to pick some events, let us know. Christian, yeah, absolutely. Drop me a note. So that'd be great. Okay, cool. Well, let's wrap things up. Thank you, everyone, for watching. Thanks for putting up with us on this longer show. Sorry, but I think it was important.
We blathered at the beginning and had important talks at the end.
Yep. And we will see everybody next week.
Sounds great.